I'm Nishant, Kaushik. Change of state since the last time I was here at Cloud Identity Summit. Last year I was the CTO at Squid. It got acquired by CA, and so now I'm over there helping them define and build the next generation IDaaS solution. So the only plug of the evening, if you want to find out more about that, we're going to be launching pretty soon. Please come and find me. My most stable persona is actually Nishant K on Twitter. So if you want to engage in discussions about the mysteries of identity management, privacy, and what the heck it is that Brian Campbell actually does, connect with me there and we'll have some good discussions. Before I start talking about security or the future of security and my concept of the self-defending enterprise, I wanted to talk about something that's a little bit much more important than that, and that's hashtags. We live in a world where hashtags are pretty important or prominent in our daily lives. How many people here use hashtags in daily verbal conversation, like me? A few. Good. Hashtag we are such nerds. Okay, so the rest of you can take it from me that hashtags are actually pretty important in our daily lives. And there's none that is more powerful or more feared than the hashtag fail. It's like the infinity gauntlet of the hashtag universe, if you will. CEOs and CISOs live in daily fear of the hashtag fail showing up on Twitter in association with the company name, especially if it's associated with hashtag breach. And for good reason, right? The numbers basically show a problem that's converting into an epidemic. I mean, I put this slide up a couple of months ago, and I can't keep up with keeping this maintained. The numbers just change on a daily basis. It's really hard to keep up. And what's even more remarkable is the names and the scale that's involved in these breaches. It's really remarkable to see that. And the question is, who do we blame for this? Who can we turn that look on? That cold, lifeless look full of disdain. It's really time for us to sit down in a circle and think about what we've done and what we can do to improve the situation. So if you think about security, we've actually built a security architecture that's very human-centric. And I don't mean that in a good way. Our current security architectures rely on our security professionals to be soothsayers and psychics. We require them to figure out every single possible way that an exploit could be brought to bear in penetrating our enterprise. We require them to figure out every single way in and out, all the exploits that are possible, and what they can do to lock those things down. We require them to actually figure out how all the workers in the enterprise are going to work together, how they're going to collaborate, what they need to do, or what access they need to have in order to do the job that they need to do. Foresee all those ways in which they need to collaborate, and then figure out what is the exact access that they will need in order to do that, and figure out what the groups are and what the policies are, and define all of that ahead of time without knowing anything about what's coming down the road. So that requires an awful lot of prescience, and the only person I think of who actually has that amount of prescience is Bob, who's really perfected the whole floating head thing, showing up from time to time and telling us that we're all wrong and what we need to do to fix things. The other thing that we do is we treat our users as gamers. We ask them to play this game where they have to figure out the access request system. And they need to go on this quest to gather all the privileges that they need in order to do the job that they're meant to do. And by the way, in order to do that, they have to go through a never-ending series of challenge responses that they have to answer. And it's continuously escalating over time, and it keeps interrupting the work that they're doing. And by the way, there's no save function. So the next time they have to do this, they have to go through the whole thing all over again, and they have to keep responding to the same challenges over and over again. So it's mind-numbing for our end users to deal with. And obviously, therefore, everybody's looking for cheat codes, right? Everybody's trying to figure out a way to beat the system. So what we've really done is build a security architecture that relies on human components, that relies on humans as the building blocks of the architecture, which is fundamentally not scalable, right? If you think about it. Humans are not meant to deal with bits and bytes in the way that we're asking them to do at this point. And this is even before the modern enterprise came along, the modern IT environment that we're dealing with today came along and broke the proverbial back of this architecture. In the modern enterprise, our workers are dealing with anytime, anywhere access, demanding anytime, anywhere access. And they're doing it on a multitude of devices in a multitude of ways. If you're like me, you work from coffee shops and airport lounges just as much as you work from your office or your home. And not only are you dealing with one device, you're dealing with, we all sort of work on multiple devices at this point. But again, much to the chagrin of my wife, those devices change every 2 years, right? I go on and I buy a new iPhone and a new iPad pretty much every 2 years, whether I need it, as I claim I do, or or I don't need it, as my wife claims I do. So the IT environment is dealing with this ever-changing spectrum of the border disappearing. The perimeter has completely been disrupted, that the traditional border perimeter that the security architecture was built on. And we've also completely disrupted the access control paradigm, right? Access control is now dealing with a more agile and fluid environment, where it's the actual end users who are defining and responsible for distributing access and privileges within the environment. Sharing is the new way of collaborating in order to be more agile, in order to be more fluid. And so when you have that happening, IT is no longer in control of your groups and your policies that define who has access to what, because, again, they can't foresee it, but secondly, they're not in control of it anymore. You've now moved to a model where your access control lists are actually end-user managed as opposed to being IT managed, right, in all these cloud services as you go through them. You're dealing with an API economy that is now connecting all these different services using APIs, and so you have a ton of data going back and forth, a ton of identity information going back and forth through different services, enabling all that collaboration, but taking away visibility and control from your IT security professionals. And that's before the Internet of Things showed up. Wait, settle down, Paul. This is not your talk. The Internet of Things showed up and sort of basically completely changed the scale that we're dealing with here. You're talking about data, tons of data endpoints and identity endpoints now that are each collaborating with each other and have very few controls, as we heard in the talk earlier, and very few identity controls and security controls around them. Exploiting this entire environment is a really sophisticated set of cyber attacks and malware that understand those holes, those gaps in the security architecture, and are exploiting them, right? They understand that the human is the biggest weak link in the security architecture. So they're going after that with sophisticated phishing attacks, with malware, with basically malware that knows that we rely on static analysis and therefore does whatever it can to try and ensure that the patterns for attack change constantly and defeat those environments. So what we've basically done is effectively destroy the crystal ball that our security professionals have been using for so long to predict what the attacks could be and therefore protect us against them. But these same challenges that are breaking our security architecture are also creating an opportunity for us. They're creating an opportunity for us to completely redesign and reinvent what security looks like. We have the opportunity to have a new security architecture, one that is more flexible, one that has a better user experience and is therefore less flawed, one that is able to adjust to the environment, to these changing dynamics as they were. And obviously, it starts with identity-based security. Andre, not your talk. Sorry. Identity-based security allows us to have a security model that transitions from a very static security environment to one that's much more secure, while also being much more flexible and even more human in its experience, right? We're all used to these models where you have basically a token, and anybody who has that token can get in. And now if we transition that to this model where you're basing it on identity, where you have multiple layers of security, the user has to authenticate to the device. The device has to have an app registered, which is authenticated to the service. The service is authenticating and pushing down information regarding the room to that device. You have all these different layers that are adding additional layers of security that make it non-transferable, that you secure it. And at the same time, from a user perspective, this is actually much better, right? So you have security, you have flexibility, and you still have user experience, right? So the challenge that was thrown out in the morning today, in the earlier keynote, about we need to sort of make sure that we don't make the user experience worse. I disagree. We actually have the opportunity to make the user experience far better by leveraging all these factors. The reason identity-based security works so much better is because it has a lot of context information, right? And that context comes from the fact that our identities are now connected to apps and devices and locations and projects and communities and files, all in a vast identity graph that brings all that context together that you can now leverage in making decisions, in making what I call high fidelity context-based decisions, right? You can leverage all this information and plug it into the network where each of these components can be the center of a graph that can drive a security decision. So you can leverage this information to make more contextually aware decisions. So when I go and I authenticate to my service, the fact that I log in to my services from a coffee shop may be known to the graph, but the fact that I log into my work service or my WebEx account from the same coffee shop twice a week, that happens to be the coffee shop that's right next door to my son's taekwondo class, is information that's now captured in this graph and can make better risk-based decisions regarding my access. When I combine that with all the log information and sensors that's available within that graph, I can also combine that with a series of information that is flowing through the network, right? So we have these shared signals that can be communicated between different services. You can have one service that understands the context of that identity within that service, communicating a common understanding of an identity event to other services that have agreed upon that common understanding. And that allows us to knit all of those events without sharing deep data, without sharing deep context, but still knit it together into a consistent identity fabric that can help you understand what's going on. So if you have your email account getting compromised, the fact that your email service understands that the account is getting compromised, it can communicate that out to other services, like your Netflix account, that can understand that. Now take that to the enterprise level, right? If your corporate environment detects an identity event in the enterprise, it can communicate and signal that out to the various cloud services that your enterprise is connected to. So while you may not have the deep kind of integrations that you're used to in an on-prem environment, you actually have this common language that you can speak to that allows all these services to take remediation action and adjust to those threat vectors really fast without requiring a lot of data going back and forth, without a lot of deep data integrations that you have to do up front. So you can do that. You also have web automation tools like If This Then That and Zapier that allow you to do uncommon integrations, things that each individual consumer or each individual enterprise can set up that are highly unique and highly tailored to their environment. So when you have this common understanding-based shared signal and this unique contextual integration that you set up between services using these kind of web automation tools, you create this sort of network effect that allows you to have better security because you're communicating information in a more standardized and contextual manner without having to set up a lot of these things ahead of time. Now, all of this relies on and also produces vast mountains of data, right? And dealing with this kind of data is pretty much a superhuman task, so really you don't really have any way of doing it in the way that we traditionally have done, where people would look at log reports and people would let me sit down and look at the logs and put a time filter basically on it, and that's enough. With this kind of amount of data, you really don't have any way of dealing with that. But what we've seen is that there are various analytic methods that have emerged, especially things like machine learning, that really allow you to get a handle on sort of the volume of data that we're talking about here. And what I was alluding to earlier about the fact that cyber attacks have now understood the sort of static nature of our analysis and therefore have now adapted to basically making sure that each time they make an attack, they try to do just enough change so that they can avoid that. Well, what machine learning allows you to do is not necessarily detect the attack, but what machine learning is really good at, which humans are not, is consuming vast amounts of data and finding repeated patterns. And what that allows you to do is build up understanding of what is good behavior, what is normal behavior. And therefore, by the process of elimination, you're able to sort of isolate out what are potential threats, potential attacks, and then sort of route them into either a quarantine zone for review or some kind of decision making. So it sort of allows us to sort of get rid of the noise and really hone in on the problem. What machine learning also allows you to do is sort of do analytics across many different kinds of configurations and settings and sort of identify what are common practices, what are common settings that people and configurations that work, and therefore then use that to isolate which configurations are sort of off from the standard or deviating from the norm, and figure out what you need to, and sort of isolate them for review and remediation. So with machine learning, you're able to do all, sort of get a handle around that vast amount of data and really use it to leverage the information. And I've sort of given this talk a few times before, so I kind of know that what some of you are thinking is, you've seen this movie before, right? And I want to make sure this is not about Ultron, as much as I love the movie. This is not about creating Ultron or creating Skynet or whatever your favorite digital boogeyman is. We're not even talking about artificial intelligence here, quite honestly, no matter where you fall on the spectrum of believing that it's going to destroy us all or not. What we're really talking about is not Ultron, but rather more like the Hulkbuster, which is we're creating a shield that leverages a lot of information, a lot of technology, a lot of the most modern technology, is contextual to our attack vector, is contextually intelligent about what it's trying to deal with, and leverages all of that to create a really strong protective shield, but still has a human in charge. We're still talking about a human at the wheel making the decisions, if you will, right? So it's really about creating more intelligent decision supporting systems with some amount of decision making where you can really talk about the fact that you sort of eliminate sort of the low-level decisions, eliminate the noise, and really allow your security professionals to focus on the higher-level decisions that need to be made. When you're talking about all this kind of, but like I said, a lot of this is really fueled by this vast amount of data and really creating all this algorithms and protocols in there. And so what you really need is to ensure is that the system has what is called algorithmic accountability. There is a big field emerging in data science called algorithmic accountability, tongue twister, which is all about making sure that while you define the algorithms that eliminate sort of the elements of human bias and eliminate the elements of human weakness in dealing with these vast amounts of data, you don't fully eliminate the human element. You still have transparency, and you have the ability to have open reviews of what decisions that are being made and understanding why those decisions are being made, so that you can, in certain cases, overturn those decisions or understand and learn from them and therefore adjust the algorithms as you go along. So having that element in there that makes sure that you have the right controls in place is absolutely critical. And obviously, with all this data that's flowing and all these pieces that you're dealing with, you also want to make sure you have privacy taken into account, so that people who have personas or multiple personas or want separation of their pieces have control over that, right? They don't lose control. They're able to exert their influence. And you get into project insight. Well, I'm getting a little far. I just wanted to make sure I got some Avengers into my deck. So anyway, basically by combining all of this, by the way, Laura, I look forward to the hashtag where the hell is Bucky tweet that I'm sure is going to come. Bit by bit, basically, we combine all these different elements to create a security architecture that is automated, right? And the security architecture is built around the fact that you're transitioning from sort of manual challenge response-based authentication to multi-factor authentication that is built on multiple passive factors in the background, working in the background, not bringing in those human weaknesses into the picture again. You're moving into a state, by relying on that, you're moving into a state of continuous authentication. And continuous authentication allows you to not only increase the security over time, where you're not only authenticating at the beginning of the session, and then after that, you trust whatever's happening. You're also moving into a state where continuous authentication is able to leverage those signals that are coming in and those attacks that are coming in and dynamically adjust based on that. You're able to feed into a risk-based decision matrix in the back end. You're able to incorporate machine learning to sort of analyze your environment continuously and continuously adjust, identifying new configurations that need to be created, configuration adjustments that need to be made, et cetera. And that allows you to get to this point where you have the self-defending enterprise, whose security architecture is agile, as the business needs it to be. It's flexible, it's adaptable, and it basically is able to evolve with at the same rate that the threats that we're talking about here evolve. So when we get this in a few years, and by that time, hopefully, as I believe Pam will have escaped the maths and madness and will be CTO or CEO of Ping or anywhere else, and she'll be running the company like she does, and she'll be working hard, and she'll be up late at night, really late at night working, and she'll get this email from Ian, and because it's late, she'll be tired, and so she'll miss the cues, she'll miss the things that tell her that this is a spam email, and she'll click on the link, right? And thanks to the self-defending enterprise, nothing will happen. Her accounts won't get compromised. There will be no breach that will happen. In the morning, there won't be any tweets with the hashtag fail or the hashtag breach. And the worst thing that she'll be dealing with that morning is how to unseed this. So with that, thank you for your time. And I am open for questions if you have any time left. I will be tweeting a high-fidelity version later.
First question is, what do you have against Ian?
He knows what he did.
Second question is, how soon do you think this is going to happen, and maybe in what phase?
So it's a constant evolution. A lot of this is already happening, but it's happening in sort of silos, right? So you see, for example, machine learning has definitely taken hold in a lot of security protocols. Like you heard Alex talk about it earlier, that Microsoft is taking a deep interest in rolling that out. Many companies are. There are many startups that are doing the same thing. Machine learning is sort of the hottest topic in this sense. You also have a lot of these, there's a lot of companies that would get classified as security automation. So sort of you're seeing the beginnings of that. Let the system take the low-level decision and deal with the noise, and allow security professionals to focus on the higher-level issues and sort of bubble up sort of those the data in a more human-readable manner to allow better decision-making rather than just going to the log and sift through 10,000 log records, right? So there's a lot of that kind of stuff that's already happening, but it's sort of the building blocks pieces that are happening right now. And so sort of combining all of that into various elements is an evolutionary thing that will be happening over the next few years for sure.
Any other questions? We're recording this, so that's why I've got the microphone right here.
Hi there. What do you think some of the performance challenges and/or maintenance challenges might be with this automated approach?
So I think the performance challenges more rely on the inter-service communication level. So within the services, there's a lot of, so with the data analytics the way they are today, there's a lot more that you can do today than you used to be able to do, but the challenges still are in how do you weave together the various services that need to rely on each other. You don't want to have everything in one service, right? Because that's really where it's going to start to fall apart. And so having these concepts of shared signals, which folks like Andrew Nash are working on at Confirm, and having sort of a change in the mentality, if you will, of the security professional to sort of understand that let's not try and solve every single problem in our unique way and define our business as our unique business, but rather leverage best practices, leverage tool sets that give you a lot of capability out of the box, and deal with loose orchestrations around these services. So there's still work that needs to be done. A lot of it relies on standards, obviously. Standards need to be defined and refined and really adopted, right? So a lot of that will be the key. But I think a lot of it can be done in a performant manner if we rely on sort of, think about it this way. There's really some really simple things that we can do. If everybody switched to two-factor authentication, password phishing would be gone forever, right? So there's simple things that we can do to really make a huge dent and get sort of from 0 to 60, and then it's the 60 to 100 thing that's really where some of the challenges are going to be.
Any other questions?
So machine learning's a cool banner. Can you quantify what, when you're talking about these signals, which we've all been rattling around for some sets of years, what's the relative complexity of these signals? Is this pretty much an algorithmic problem, or really something that machine learning needs to tackle?
So I define signals as standardized understanding of basic events, right? So it's more standards oriented. So that's why I kind of, in that slide, I was kind of defining the separation between the shared signals type stuff, which is more standardized event-based things, which you sort of different services kind of agree on. So if you think about sort of even at the federal level and all what Microsoft was talking about, just sharing some basic information, which can make a huge dent. So that's one aspect of it. And then the web automation stuff is more custom, where you understand how things work. So for example, one of the things that I'm dealing with is, for example, as soon as somebody joins a project, immediately go and communicate the fact that or creates a project in Asana, for example, immediately create a role within the identity management system that understands that there's a project, and as people get assigned, it deals with that automatically. All of that today happens manually, and you can really cut through a lot of the crap in security by just saying, let me just build that connector using Zapier between Asana and my IDM system and let it handle it. It's unique, it's contextualized, because it contextualizes to your business. But that's separate from the signal stuff. And the signal stuff, it's like any standards effort. It can start with a basic set and then grow over time as we identify what's important.
And with that, we're out of time. Thank you very much, Nishant.
Thank you.